Why?
All right, we're gonna get started now. So this week we're just talking about authentication, but first some administration things. So PA5 was due last night. That was actually the last assignment for now, other than the final project, which will be part of the hack challenge. So that starts next week, and attendance is required for that lecture. So
Well, it's not actually going to be a lecture. It's going to be like a kickoff event. So basically, yeah. So we have like the three classes: iOS, Backend, Design, and like basically students from all three classes will be here at this time from like 8:30 to 9:30, and then all of like the other instructors will be here, and we'll basically sort of go through an overview of what it is. So it's like a hackathon, except it's like over a
two-week period.
2 or 3 week period.
And that'll be your final project.
Yeah, and it'll be the final project for this. So you'll get to like apply all the concepts and stuff, um, and work with other people in other classes. And after next week, so the lecture after that will be on deployment. So we've like our class has always partnered with Google Cloud in the past. So we have like Google Cloud credit signups, so that you guys will be able to host like the applications that you guys write on Google Cloud. And then we'll be going through that in 2 weeks. So that will be the lecture after the Hack Challenge kickoff. So.
And then some other app dev announcements. Eatery is now out on Android. So before we only had the iOS app. So if you have an Android, you should download it. And then there's also going to be an update for Eatery on iOS coming out probably tomorrow. And then also, we just released a new app on iOS. It's called Uplift. So it's like fitness. It's a fitness app. So it's basically like Eatery, but like for gyms. And like you can see like gym classes and everything. So it's out in the App Store. If you like search like Uplift Cornell, you should see it. Yeah, Young worked on it actually. All right, so now we're gonna get into authentication. These are just some of the topics that we're going over today. So what have we learned so far? So basically, from your previous assignments, you guys know how to make a basic backend that supports like a social network, like creating posts, commenting, but how do we incorporate users now? Because before we would just send like a request with like the username, and that was pretty much it. So like in any sort of application with users, there needs to be a way where you can verify identities. So like previously, like in your assignment, when you wanted to create a post, you would basically just send a post body with like the text and the username. But you could like basically put any username, like you could impersonate other people, and like this is like not good because anyone could just make posts with some username, even though that might not be them. So today we're gonna go over like how does the server authenticate people? Like how does it tell that you are who you say you are? So yeah, what is authentication? So basically, it's like how the server validates who you are. So yeah, it's basically authentication, like generally is a process that ensures and confirms a user's identity. So an example is like when you sign up for an account on a website, when you first sign up, you like put in your name, like your username, password, and what the website does is it stores your credentials securely. So for like passwords, it never stores your passwords in actual plain text in the database. It will usually do some type of hashing and encryption to make sure that's safe. So like even if someone like hacked the system and like had access to the full database, they wouldn't actually know your password. And yeah, to sign in, you would give it your username and password, and the server would check. So here's an example. So like on the left, we have like the Facebook login/signup page, and on the right, you can think of as like databases that Facebook might have. So when you first sign up, you like give it your first, last name, password, and all this other information. And what happens is Facebook, their servers will encrypt these credentials and store them in the database. So then when you log in, it will check that email that you entered. It will search the database for that entry, and then we'll check your like hashed password against the one that's currently in the database. Yeah. Usually it just checks email, right?
Yeah, email doesn't get hashed.
Yeah, usually it's just passwords that get hashed or other like sensitive information like credit card numbers or stuff like that. Yeah. Does anyone have any questions so far? Yeah.
Would there be a reason that you don't hash the email? Like, is it insensitive to hash something?
Um,
So I think like, let's see, why don't they hash the email?
I mean, usually like you only do it for like sensitive information.
So yeah, I don't think there would be like any. There's no like obvious con to not doing it, but I don't think like
Generally, people
yeah,
don't.
generally like
use
people
it.
like your emails are pretty accessible anyway, so there isn't really a point in doing it. But for like passwords, like the hashes that they run on passwords are like extremely complex, like multiple algorithms to like make sure that it's completely secure. So those hashes are generally pretty expensive.
Yeah, so we're going to be focusing on two types of authentication. So there's the basic authentication and then the more commonly used one, which is session authentication. So how does basic authentication work? So basically what you do is you send your username and password to the server, like say like you log in, and then if that's successful, then the browser caches those credentials. So it caches your username and password, and it basically sends these credentials on every request to the server. So like when you make a request, like there's like the body of the request, but then there's also something called like the header that contains like metadata, and this is where your credentials are sent. So if you look at this, say like I wanted to access some like protected endpoint, like my files on Google, but only I can access these. So how basic authentication would work is in the header, you would have this authorization keyword, and then basic, which basically says that this is like the basic, which is like the type of authentication that you're doing. So in this case, basic. And then how your username and password are actually sent is it uses like this base 64 encoded version of your username colon your password. And I believe this is like foo colon bar. But this is actually very unsafe. Like this is not actually encrypted or hashed in any way. Like if you look up like base 64 encoding, you can basically decode this very easily. So like this was like the very basic version of authentication. You should never use this with just HTTP because HTTP doesn't actually encrypt any of this. So anyone could just look at your like web traffic and basically extract your username and password from this. So yes, security risks. So with every request, your username and your password are sent. So you have this like very large attack window. Yeah, and then your username and password are exposed in each request. And then also with this, there's really no way to log out. So your credentials are actually stored in your browser until you like quit it or close it, or the user like clears their history. Does anyone have any questions about basic authentication? All right. So the more important one that we really want to focus on is session authentication. So what is a session? So a session is basically a time frame where the client or like the user and a server are interacting. And basically like, say like you log in to Facebook. This like basically starts like a new session. And what like a lot of websites do is like if you log into a website, like you can go on it without having to re-log in for a certain period amount of time, and then usually like it will expire after whatever time limit. So a session has metadata that the metadata associated with the session includes like the user that the session belongs to. So you can think of this as like a one-to-one relationship. Every user can only have one session at a time, and every session can only belong to one user. So it's basically like the time period of like a user being interacting with the server. And then you have something called a session token, which is a unique identifier, an expiration date, so basically when the session is over, and then a refresh token. So basically, if your session is about to expire, you can send it a refresh token, and it will renew that session. So like it will change the expiration date, it will give you a new session token and a new refresh token. So this is basically, so sessions are usually implemented by like creating like a table for them. So this is an example of the fields that like a session table might have. So like the session token, when it expires, an update token, and the user it belongs to, if you look at the very bottom row. Does anyone have any questions right now? Yeah, so how this works is, so a client will sign in with their credentials. So like they'll send a post request with like a username and a password. So then the server will then check these credentials to make sure that the password matches the user who sent it. And then it creates a session for the user on like in the database, let's say, and then it gives you a session token. So if you look at this, the client in the very top arrow, the authenticate, that's basically the client just sending a request with their username and password. And then the server will respond and give them this like session token. And in most cases, when you get the session token, your browser will save it as like a cookie. So then after you send your username and password and get the session token, so your browser either stores it as a cookie or on the disk securely. And then what happens is with every request after that, rather than sending your username and password every time, you just send that session token. Because on the server side, when a new session is created, it stores like the session token and like the user that's associated with it. So like the server can uniquely identify you with that session token. So in this case, the client sends a GET request to profile with this session like ABC. So like that would be like the session token in our case. And then the server can look up like whose session is this to verify like who the user is. And then if that's like a valid session or like a valid user, then it'll give you a response. So like if like the user sends like an invalid session token or just like nothing at all, then the server will realize like, oh, this is not like an authenticated user, like return like an error request. Does anyone have any questions about any of this? Yeah.
This diagram top to bottom is over time?
Yeah. So like, so first like the user sends like their username and password, the server responds with some type of session token, and then from there, with each request that the client makes afterwards, they send that session token to the server, so then the server knows who sent it. Does that make sense?
Also, like, I think another, like, an analogy that we could use for this is, like, for, like, basic authentication, it's, like, if you ever, like, got an ID and then you have to, like, bring your passport, it's, like, basic authentication is, like, you have to bring your passport everywhere with you and to, like, authenticate to say, like, oh, this is actually me, right? And then session authentication is, like, if you bring your passport and then you get like an ID card that like signifies that you've brought your passport, and then you can use your ID now to authenticate. And then so it's like, oh, what if someone steals my ID, right? Is it actually more secure? Which is why there's like the session has an expiration date, and then you can set that expiration date to be like relatively quick, so that even if someone like steals your ID, steals your session token, they won't be able to authenticate with it for a long period of time. Does that make sense? Yeah.
And yeah, so like when the user's session token expires, they can always send a refresh token to renew their session, basically. So like the benefits, so like your username and password aren't exposed in every request. So like Young said, like you don't have to bring your passport every time. It only contains the session token. So like even if someone saw it, like they wouldn't know your username and password. So it's like much safer. And also, yeah, like session tokens have an expiration date. So even if someone like saw your session token and was using it, they can only use it for so long before it expires. And also with sessions, you can have restricted permissions. This is like not super important, but yeah.
Yeah, so the restricted permissions is like if I could, I don't know, if like someone could bring my passport to like anywhere and then, I don't know, steal like my credit card information, like maybe I just have like a Cornell ID, but if someone has my Cornell ID, they can't go to the bank and be like, oh, I'm like Young or something, give me all his money, you know? Like it has permissions that's associated with it.
Like if you ever go like on any like website and if you want to try to change your password, you would have to enter in like your old password before. So like if someone like using like the basic authentication saw, you know, your username and password, they can go in and basically change all your account information. But like with a session token, they don't know your actual password, so they can't go in and like change all your information basically. So basically, how is session authentication designed on the back end? So yeah, usually there's like a sessions table in the database that stores for each session a session token, an expiration date, and a refresh token. And then also each session object should also have a foreign key that refers to the user object that the session belongs to. So yeah, like so this is an example of like a SQL query for creating a session table. So it basically has all the fields that I talked about before with the foreign key to the user ID. So when a user successfully signs in, a session object is created for that user, and it returns to that user the session token, the refresh token, and the expiration date, which they can now send session token with each request. So when the user makes a request, they send the session token, and the server can now use that token to look up in the database to see, like, first of all, does this session even exist? And then also find the user associated with it. So basically how this would look on the database side is, say the user sends the session token in their request, we can do this like select query. So like select, like find the user ID from the session table where the session token is equal to the one that was set in the request. If this has no match for any like user ID, then we know that the session token was invalid. But like say it returns us like some user ID. So now we can go to our user table and select star from our user table where ID is equal to that user ID that we found from the previous query. Does anyone have any questions about how this is, like why we do this or how this is implemented? All right, so another very popular type of authentication is called OAuth, and 2.0 is like the current version, I guess. So basically, if you ever go on to like pretty much almost every site, you can log in with your Facebook or Google account without having to make a new account for that certain website. So for example, it's like Pinterest, you can, if you look at the bottom two like buttons, you can like log in with Facebook, Google, which saves you the hassle of having to like, you know, create another account. So the stakeholders in OAuth 2.0, so basically like the parties are involved, is like the third party client, the application or site that you're trying to log into. So like in this case, like we're trying to log into Pinterest, and then the API, and then we call this like the resource server. So in like the previous image, it's like Facebook or Google, like what you're using to try to log into the third party client. And then the resource owner is like the user. So it's like basically you, because you you're using, it's like you own the resource, so like you own like a Facebook account and you're trying to sign up for Pinterest with that. So the benefits, it provides streamlined way of registering users. So yeah, it's kind of annoying whenever you have to like make a new account, like put in your email, like a new password, like you have to fill out all this information, but it's very easy to just be like, oh, I already have a Facebook account, I can just log in with that. So it makes it very easy to get users to sign up, and it's much faster. So how does OAuth work? So we're gonna walk through examples. So how an application like Pinterest, we call this like the client, can allow users to log in with their Facebook account. And Facebook in this case is our resource server, because we're using like existing, you know, Facebook accounts to help us log into Pinterest. So first, Pinterest has to let Facebook know that it wants to use their login. So it tells Facebook like, hey, I want to use like, you know, OAuth, and I want to be able to have users like log in through you. So Facebook will give Pinterest a client ID and client secret, so that Facebook knows that like whenever Pinterest sends like a request to Facebook, it sends like their client ID and client secret. So Facebook knows that it's Pinterest interacting with them, not some other website. And then there's something called a redirect URI. So like if you were on Pinterest and you like press like the login with Facebook, it will redirect you to Facebook and like you enter in your credentials. And then after you log in, it will actually redirect you back to Pinterest to some like landing page. And like what Facebook redirects you to after you log in is called a redirect URI, which is basically just like some website on Pinterest that Facebook is going to redirect you to after successfully logging in. So basically there's like this kind of like two-step process. So Pinterest would have some type of button on their sign in or sign up page that links to something like this link. So like in like the very first image when you saw that button that says like sign up with Facebook, it would link to something like this. So if you look at the parameters, like response type is code. And basically before you can access anything, you have to tell Facebook, hey, I need like this authorization code. And then you specify the client ID, basically saying like, this is Pinterest who wants, this information, the redirect URI, so where Facebook should return me to after logging in. And then scope is basically like declares the resources that Pinterest wants from Facebook. So like one thing, like, so like if you go on Pinterest, like you can like find, your Facebook friends that are already on Pinterest. So like in this case, scope is like friends and timeline. So it's like telling Facebook like, hey, like I want access to this person's friends and like all the posts on their timeline. So that's basically telling Facebook like what resources we want from them, which is like why they're called like a resource server. And then this like state is like some randomly generated like string for security purposes. So after you like log in and then sign up to Facebook, and they redirect you to some type of URL that would look like this. So it'd be back to Pinterest, and then you would have this authentication code now. So basically now that you have this authentication code, okay, so yeah, so in the beginning, this is just pointing you to, like Pinterest is on the very left, and then you have the user on the right, and this is just like when you first log in to Facebook through Pinterest. So that's like what those first couple steps we're going over. So like, if you look at this auth code here, basically what we use that for now is we can now send our authentication code to Facebook to get this session token. So you would make a post request, and grant type, you would say like, hey, I have an authorization code, and then you would insert, the authorization code plus like your redirect URI, client ID, and client secret from like the first steps. And this will basically, so if you look, the authorization grant is Pinterest sending Facebook this authorization code, and then Facebook will give Pinterest an access token. And now what the access token is used for is, so like say I log in and it's, and like Pinterest wants to get all my friends on Facebook. So it can use this access token to ask Facebook, hey, give me all these users' friends. And it will send them all these, so basically this access token will give it the, previously we like specified like the resource that that Pinterest can have access to on Facebook. So like in this case, we said like for the scope we said friends and like timeline. So basically this access token has the ability to get those items from Facebook for this particular user. So that's what like protected resource means. So that was a lot. Does anyone have any questions about this? OAuth is a very confusing process because like there's so many steps. But yeah, that was trying to do like a quick overview. Yeah.
So I see how that lets like Pinterest access Facebook's resources.
Yeah.
Is there anything about like how a user uses that to interact with Pinterest's resources? Like does their browser provide a token to access resources on Pinterest or Facebook?
This token that we get from Facebook allows Pinterest to get data from Facebook about us. So like when you like first sign up for like say Pinterest, you have to enter like your email, like your name, like all this different information. And like what Pinterest like would do is like they're signing up through Facebook. So instead of them entering all this information about themselves, we're gonna try to get all this information from Facebook ourselves. Does that make sense?
Yeah, and then, but when you use that and you just access resources that are on your personal Pinterest account that you authenticated through Facebook, does Pinterest have its own authentication scheme between you and Pinterest?
Oh yeah, it does. So like that's only used for like Pinterest is using it on your behalf. That's why like you get those like annoying things like when you log in on stuff. It's like, oh, this like app has permissions to post for you or something, stuff like that.
Yeah. All right, so we're just gonna go over like a quick or like a demo about like how you would implement this with like Flask and Python. So yeah, I'm just gonna go over it. So like there's a lot of starter code that I included. Let me make this bigger. All right. So yeah, if you look, so basically, so for our purposes, we combined users and sessions into one table because we know that every user is only going to have one session and every session is going to have one user. You can always decouple them, but for our purposes, to make this more lightweight, we combined them into one table. So we have this user table, which has like the ID as default, and then it has email and something called password digest. So this will be like our encrypted version of like the user's password. And then we have this session information. So we have like the session token, the session when the session actually expires, and the update token of the session for the user. So if you look in our init, so we basically just get the email provided, and then if we look at password digest, we have this line that uses like bcrypt.hashpw. So basically what this does is it takes our input for password, encodes it, and then basically hashes it. If you're more curious about it, you can always look into the documentation for this package, but yeah, it basically hashes your password in a very secure way. And then after we initialize that, we renew a session for the user. And then this is just a helper function to generate our tokens, because whenever we want to generate our tokens, we want to randomize it, so that this is just a function that does that. And then if you look to renew our session, we basically just generate a new session token. And then for our session expiration date, you see that we take the current time and then add a date to it. So we know that this session will expire in exactly like 24 hours. And then yeah, you can always modify this to whatever you want. Like some people do like a week or like an hour. It's really up to you. And then update token, we also generate a new one. So how we verify our password is there's actually a function called checkpw, which checks the password that we're given across with our already encrypted password digest. So yeah, if you're curious, I would look more into bcrypt. But yeah, that's just how it can check our password. And then to verify our session token, we make sure that it's equal to the one that we have set, and also that it has not expired. Does anyone have any questions about any of these, like how we initialize users, the functions we have? All right. And then we have this file called users DAO, which stands for data access object. So basically to like prevent us from writing a bunch of queries over and over, we just have one like, oh, like get a user by email, session token, update token. Very straightforward, a lot like some of the previous queries that we had to do. And then we have one called verify credentials. So basically it's given an email and a password. It first checks to make sure that a user is associated with this email. If it's not, then we return false, or else we also verify the password. creating a user is pretty self-explanatory. We just make sure that a user doesn't already exist with that email and then create the object like usual. And then renew session is pretty straightforward. So whenever a user wants to renew their session, they send their update token. So we can find the user that sent this update token by using our previous method. And then if there is a user, then renew their session and then commit it to the DB. Does anyone have any questions about this implementation so far? All right, so now we're gonna do some of the routes. So if you look, we have some routes like hello world, and then like register, login, updating a session, and then some type of like protected endpoint that we want. So basically how you would implement this is for register account, you would just like always get the post body and then extract the email and password. And then we make sure that email and password are both not null. So we say if email All right, so say now we have like a valid email and password. We want to create a user with these credentials. So we're going to use our, if you look right here, our create user method from our user's DAO file. And you can see that it basically returns like whether something was successful or not with a user. So in this case, it returns true if it was successful and the user that it just created. So we can say and then we can say if it was not successful, then we know that this user already exists. If not, then we want to return the session information associated with this user. Does anyone have any questions on how we did this register endpoint? All right. So now we're going to do like how you would implement like a login endpoint. So like before, we basically want to check these same things. We want to extract the email, password, and make sure that they are not null. And then we have, if you go back to users DAO, we have a method called verify credentials that takes in an email and a password, and then returns whether it was, if the credentials are correct, so either false or true, plus the user associated with those credentials that were sent. So we can have our success variable and the user. And then we can basically do the same thing. So if not success, then we know that either the email or the password were incorrect. And then we want to, and if it was successful, then we want to return the same session information to the user. Then we got to import file. Yeah, so one of the things that is different about this is, so like before with request, we would extract things from like the post body, and how we did that was like this JSON.loads with the request.data, but how do we extract things from the header? So we have this method up here called extract token that will take care of that for us. So how we can do it is we can specify a variable called auth header, and we can do the same thing with our request object that's given as parameter, and we can do dot headers and dot get and then authorization. So basically when it comes to headers, it's generally like follows the form of like a key, so like in this case authorization, and then like a value that goes along with it. So in this case we're looking up our authorization, the value for that key. And then we can check if this is null, then we can return false, and then like an error message. So this will actually be used in one of our routes later. And we can say missing header. And then, so usually our header would look something like this. So generally it would be like authorization, and then it would have a colon in it, and then the general form for like session verification, like submitting, like sending in like tokens, it would have, you put like this word bearer, and then you would have like the actual token.
Wait, can you guys see the comment?
Yeah, I don't know if it's...
You want to just not comment?
All right. Okay, well, I'll explain it here. So...
Maybe you can put it in triple quote.
Yeah. That's... Is that still a...
Yeah, it's legal.
Okay. So yeah, so like usually if you look in the header, if you get authorization, it's gonna have like the string like bear, and then like the token. Do you know why it's called bear? Yeah, it's just like common like practice to call it that. So how we can extract the token from that is we can get our auth header, and we can say replace bear with nothing. So basically this takes, so like what it would look like when we do auth header dot get authorization is like the string that contains basically like this part, and we only want the session token, so like one way of extracting that is just basically getting rid of this part. So that's why we do that. And then we can say if the token is none, why is it or not bearer token?
We don't.
We can return false. And say invalid header. Go back. And if not, then we know that there's actually a token, and we can just return true and that token. So yeah, so we're actually going to need this for update session, because when you want to update a session, the user would generally send a refresh token in the header themselves. So basically how we would do that is we would say success update and use our extract token method and give it the request object. And then we can say if not success, so if it failed, we can return update token. So like, it's a little misleading why we return update token, but if you look at our method up here, whenever we return false, our second object that we return is actually like this error message that wants to be sent to the client. So that's why we do like if this is false, then return the second object, because we know it's going to be one of these error messages. So after that, then we can try to renew the user session with this update token. So if you look at back to users DAO underneath the renew session, basically gets the user by update token, but if the user is none, then we raise this exception, which is why we have this try catch block. So we try to get the user associated with this But if there's no user, then we just return this error message that says this is like an invalid update token. And then basically we want to return the same session information again. And then lastly, like say we have an endpoint that's protected, so like we only want people who are logged in to see this, then we can kind of do the same thing. So we can extract the session token from the header. And then we can find the user who sent this. And then if there's no user found, or this session token doesn't actually belong to this user, then we can return an error. Let's say if not, if it passes the authentication side, then we can return a successful message. All right, so how does this work? So we're gonna start it, and then I'll run this in Postman. So yeah, if I try to access this endpoint right now, I'll get this error because like, oh, I'm missing my authorization header because this is like a protected endpoint. So now we can do like our register. So we make a post request, and then in our body, we would put in, say, like our username and our password. So basically we would send this, and yeah. And then as you can see, like this is our session token that we would now like send with every request subsequently, like when this expires, and an update token if we ever need to renew our session. So if I take this session token and I try to access our like secret endpoint now, doing a GET request, so how you would do it is you would go to headers. In Postman, like it's very simple, like you have this key and this value pair. So our key would be authorization, and then we would do bearer and then like this session token. And you can see like you can have access to this message. Like say I put in, like I deleted half of this session token to make it like invalid. If I try it, it will say like, oh, this is an invalid session token. And then let's see, make this bigger. Oh. All right. So if we actually look at our database, so if I do SQLite and we try to look at our users, you can see that, yeah, so I believe, so like this is our username. Yeah, so the third field, it's actually our password digest. So if you, I believe this, one of these items is like our password encrypted. So like this is what it would look like in the database. So like if anyone like ever hacked into our database, they wouldn't actually see our password in plain text. It would look something like this. So like that's what happens when you register. Like it creates this user with all their session information included. So then if I wanted to, like, say, log in my body, I could do something like this, but like, say I put in like the wrong password. Oh, I disturbed myself. If I put in the wrong password, it would tell me, oh, like you have an incorrect email or password. but then if it was actually correct, it will give me a new session information basically.
Linked sessions or in general? Oh yeah. So something else that's like I think is kind of interesting is like thinking about how like your client and the server even establish like the secure channel of communication. So like if you think about it, well, all right. Okay, so if you think about it, like, so for something like HTTPS, it's like secure even over open networks, where like anyone could be watching your traffic. So like maybe we have like our client, and then over here we have like Facebook or something, some other application, and then you can send whatever you want, and like we're in like Starbucks or something, or something. And then so other people who are also connected to the same network can like see all the traffic that you're sending between the client and the server. So the question is like, how do you actually even establish a secure channel to like even send your username and password in the first place? So if you think about it, like one simple way is like, okay, you know what? Maybe I'm going to like encrypt my stuff with an algorithm. And I want Facebook to know what algorithm I'm using, right? So like if you had that, then you can like encrypt it somehow and then send it, and then the observers would only see encrypted stuff, and then Facebook would be able to decrypt it. That's kind of like the thinking. But then for you to tell Facebook like what algorithm or how you want to encrypt it, it's like inherently insecure, right? Like you have to send that unencrypted for Facebook to be like, oh, now I know how to decrypt this information. So the way that it works is like it's like kind of similar to RSA, or like the concept is the same as RSA. So the way it works is like Facebook will broadcast this thing called like a public key. So public key, and then they'll have a private key that they can decrypt all messages with. So they have the public key, and then they have the private one. Okay, that's cool. So we have the public and the private key. And the public key is kind of like you can kind of think of it like a safe. So if you think of it like, say I gave Megan a safe, and then she could put whatever she wanted in it, and then like even if people saw the safe that I gave to her, like there's no way, it doesn't like, they are not able to unlock it, right? So she can put whatever she wants in the safe and then give it back to me, and then I can decrypt it. That's sort of like what RSA does. So the public key is like the safe in the analogy. So I just take like an open safe, and then anyone who wants a copy of that can get it. And then the private key allows me to decrypt it. So then I give that like safe to the client, and then the client can specify however they want to encrypt or decrypt their information, and then they just like close the safe and then send it back. So any observers who are watching, they're unable to open it. They can like have the safe with the contents inside of it, but that doesn't mean they'll actually be able to know what the client sent. And then the server is able to decrypt it with the private key, so sort of like the combination to the safe, and then you can establish like a secure line of communication, since you're able to authenticate between the client and the server without like anyone else knowing what information you sent. Does that make sense? So that's sort of like how, it's like a very basic level how like HTTPS works, or like this idea basically. It's more complicated. There's like a lot more steps that are involved. There's like 6 messages that are sent between client and server or something like that to make sure that you've like established a secure channel of communication, but it's sort of like this safe idea. And then the way that it actually works in like code is they use basically like, this is sort of unrelated, but if you're interested in that, you can always Google it. But basically, it has to do with like the fact that like factorizing numbers is like an extremely computationally difficult problem. But like it's like factorization of numbers of 2 prime numbers or something like that. And then it involves that, and then a bunch of like really interesting math, and then you're able to like achieve something that's like that, like something that's really easy for you to decrypt, but really difficult for other people to guess, basically. Um, yeah, I don't know. Does anyone have any other questions related to that or anything that we covered today? Yeah, what's up?
In the decrypt class method that we were using, the method that we're using from Flash to hash our passwords,
Yeah.
like if that method is available for anyone, right? To anyone that that uses Flash could use that hashing function. So
Yeah.
how is that like anyone could use that to put any password and then access your database to see if it's the same?
I think like in wait, you want to go to the users thing?
Are you talking about
Yeah.
this thing?
Yeah. So the salt that's generated to hash the password is random.
Right.
Yeah, and then it like goes. So this package bcrypt is actually secure for password hashing. I'm not too sure on the implementations, but like the salt generated is unique, and then they like the round specify like how many times they like rehash that specific string. Yeah. Any other questions?
Yeah, in the secret method.
Yeah.
Also, can you go to that one?
Yeah.
How is that? How a user token, no, a user that you get from the session token, how can it have a token that is not the same?
I think verify session token is just to make sure that because like say like someone renewed that session but they're using like an old token. Yeah, wait, let me see. I'm not entirely sure. Let's see. This is verify. Yeah, it also makes sure that like even though you might have like a session token that's like currently assigned to that user, it might be expired already.
Also,
So
like
that's why
in
we
the
do that.
database, like the relationships between users and sessions is like one to many. So expired. So like in a dish, like I guess like the better way to do it is to have it always be one to one. But then in our implementation, it was one to many. So like expired sessions just sit in the database.
I think this is one to
Oh,
one.
this is
This is one to one. This is
Oh,
one to
never
one.
mind. Okay.
Yeah, this is just to make sure that it's not actually expired already. Yeah, that's pretty much it.
All right, yeah, I think that's everything. So if anyone has any questions, you can come talk to us afterwards. But yeah, that's it.